All right, so today's lesson on derivatives and integration, we're using the formulas at the end of the derivative and at the end of the integration formulas. And what we have discovered so far from just looking at them before I turned the video on was that sine and cosine's formulas at the bottom of the derivative section are almost identical except for a negative because cosine starts with a C. Same thing for the others. So we actually could just memorize 3 formulas and just know if it starts with a C. We just need to know that sine and cosine have the same formula except for that negative. Does that make sense? All right. So the formula on your formula sheet says U prime, but I changed it to DU when I wrote it on the board because that's what we are used to. So to take the derivative of this formula, forget about the 2 for just a moment. I'm going to come back and talk about him. First, you have to decide what's U, okay? And in these questions, U is whatever's inside of this arc sine. So if I'm going to put, I'm going to throw them in the marker around. If I'm going to put that inside of a square root with 1 minus that square, then I'm going to put x minus 1 in there. Does that make sense so far that that's how you do chain rule with U inside? And what is the derivative? And this goes back to chain rule, that you can think some of this in your head if you want to, or you can write it down like we did before, that this is 1 dx. And so therefore, if it's 1 dx, then I just need to put a 1 on top. I don't put the dx part because this is with the prime notation over here on the left. But I put the derivative on top, which happens to be 1, right? X minus 1's derivative is 1. And then I can slip that 2 up there, because 2 times 1 is 2. And also, as you're doing this, you want to square out that bottom so that you can take that 1 and subtract 1 minus that. And I usually go over to the side or underneath it and do that because I want to just fill in my formula over there. So square the first is x squared. Square the last is 1. 2 times... for double the middle, this is negative 1 and doubled is negative 2. Is everybody with me so far? And why did I write a square on that? I said square and I wrote a square. I shouldn't be writing a square. I've already squared it. So square the first, square the last, double the middle. But then I got to change the signs. Does everybody see that? That's why it's so important to write those parentheses back on it after you square it. And that makes me have the... No, because negative times each one. The 1's cancel out, so I have a negative squared and a positive linear, so they like to turn that around and make it look like subtraction. Does that make sense so far? Now, if I did this same exact problem with cosine as the arc, the only difference would there be a negative on top. Does everybody understand that? Sorry, it's the same formula. Okay. All right, so in our second example, this is arc cosine. Now on your formula sheet, if you look at arc sine and you look at the arc cosine formulas down there, the 6 at the bottom of the derivatives, just one last time, Kenzie, I'll let you tell me this time since you weren't in here. Look at the arc sine, look at the arc cosine. What is the difference in those 2 formulas? One thing. There's a negative. So you have to memorize one formula, and you can use it for both as long as you realize that it's just going to be, okay, something's not right. There we go. It's going to be a negative. Does that make sense so far? All right, so this is the formula. So go and look at those 6 formulas. As you look at these 6 formulas, all you notice is that when you go down through here, that these have a negative and these don't, and they're exactly the same. So you're going to have to learn a new pattern. Sine and cosine have the same formula. Secant and cosecant have the same formula, and tangent and tangent have the same formula. So U in this problem is always what's inside. Board's not cooperating. But U is always what's inside your parentheses. So you've got to be able to take that derivative. And once you're able to take that derivative, the rest of the math falls in place. That's right, it's 1/2. So if U is equal to 1/2 x, du is equal to 1/2 dx. Now, I'm going to tell you that it's a whole lot easier to stick this over here and say 1 up there because of multiplying fractions in. Now, you got a 3 that's not part of the derivative. He's just along for the ride, right? Coefficients just stay on your derivative. And then you've got this, negative 1 over this square root. And inside this square, you're filling in what was in that parentheses. So you're filling in x over 2. And then you're multiplying by du on the side. So the arc cosine made that extra negative come in the front because cosine starts with a C. Now, this needs a little cleaning up. Number 1, inside my radical, I need to actually square that. Number 2, I need to go 3 times a half is 3 halves. Everybody with me? Times negative 1 is negative 3 halves. Did everybody see how I put my negative 3 halves into my fraction? We good so far? And last but not least, we need to do a little bit of work on this problem because this could get a common denominator and I might be able to take the square root of the bottom then because it has a 4 on the bottom. If I had a common denominator, I could square root it. So we're going to change that to 4 over 4 so that we can put that all in one fraction. Like that. Separate it out as one big 4 on the bottom with a square root on the top. What's the square root of 4? And what do you think that's going to do with this 2 that's already down there? Exactly. So the final answer to this question is negative 3 square root of 4 minus x squared, which is a better format in the first place than a fraction. So based on what we've seen so far on these 2 examples, the only difference that I did something different here in terms of setting the problem up was the fact that I had to put the negative in the top of the formula because sine worked the same way without the negative, right? But I showed you 2 different ways of dealing with simplifying the radical. In the last question, and just to go back for those 2 that came in late, we had to square this out and add all the like terms together. And you can get this off the video later if you want it. In this question, we had to get a common denominator because we had fractions. So that's the 2 typical things that happen inside of here that you will have to deal with. All right, our next question is going to be an arctangent. So how can you describe the arctangent formula in relation to how different is it than the one we just used?
It doesn't have square root and it uses addition and not subtraction.
Okay, that's a good description. So it's du over, what does the formula in the formula book say? 1 plus u squared? Okay. 1 plus u squared. What if it was cotangent? That's right. Arc cotangent would just have a negative on top because cotangent starts with a C. So this is u. Now, in this problem, a is a number. So if u is equal to 1 over ax, what's du equal to? 1 over a dx, correct. So there's nothing in front of my arctangent to like multiply times at this time. And you really should think of this du as being over here. But on your formula sheet, they say u prime because they want to use that other notation, and that's why I'm changing it to du. So there's just a 1 up there for right now. Down here, there's going to be 1 plus whatever's inside your parentheses for your arctangent, which is going to be x over a. And I have to multiply that whole answer times 1 over a. Isn't that just going to put the a on the bottom? Okay. So now that I've got that, I probably would want to clean up the inside some. So first, let's square that out. Don't look like I need to do a common denominator again. Actually, a squared over a squared if you want to make it match this one. Yeah, because you want to make it match the inside powers. So that makes my problem, there's still got this a out here, a squared plus x squared all over a squared. Now what do you notice? One of them will cancel off that a on the outside. Now, that's a fraction within a fraction. What do you think I should do to get the final answer? Yeah, and multiplying it to a 1 just really just flips it. So that's the final answer to the question. All right, let's look at an arc cotangent, and I'll do one this time that has adding or subtracting in the parentheses so that they can see one that got squared out. All right, so in question number 4, our function is -2 arc cotangent of x plus 2. I'll just keep it real simple so it's nothing complicated. It's the same formula we just looked at, except for the negative. Everybody agree? But that's the formula on the formula sheet, so you've got to learn which words to go together so you can say, oh, these two have the same formula. Oh, that one starts with a C. And by the way, it's not the beginning of the word that starts with a C, it's the trig word that starts with a C that puts the negative. All right, so I got a -2. Just bring him down and let's start setting up our problem. All right, if u is equal to x plus 2, is the du going to need anything? Nope, because the derivative is 1. So we're just going to say -1 up there. 1 plus x plus 2 quantity squared. Now this one's a little different than the last one because it has a plus sign in front of the parentheses. If it has a minus in front of the parentheses, you have to distribute it to everything as you square stuff out. You know, you would distribute. But this one has plus, so I'm just going to square and add 1 to it. And that multiplies out to give +2, by the way, on the top. So if you square the first, you get x squared. If you square the last, you get 4. If you double the 2x, you get 4x. And if you add the like terms, then the constant becomes 5. Are we good? All right, so we've looked at sine and cosine, which has a square root on the bottom, with subtraction, 1 minus u squared. We've looked at tangent and cotangent, which has 1 plus u squared and no square root. Well, maybe we can remember it like this. When you square something, don't you always get a positive? Well, there's no square root there, so it's good, right? The minus ones are in all the others. This is the only one that has plus between it. All the others have a minus. So maybe we can think about the fact that tangent and cotangent have always gone together, so they get joined together differently than all the others. Because all the others do have a subtraction sign in it. That's true. The square roots do cause a little bit more work. So maybe we can remember that adding's easier. Would that help? Adding's easier, so tangent and cotangent are easier. So the final thing that we got to look at is absolute value of u. The square root of 1 minus u squared is on the bottom of our du problem for secant and cosecant. And secant doesn't start with a c, so it doesn't have a negative on top. It's the only difference. Did I write that right, or is it round the other way? Is it u squared minus 1 or 1 minus u squared?
Wait, it's the other way.
Other way around? I thought I might have wrote it backwards. That's another little thing you got to be careful about.
Well, that helps because now it's that secant, cosecant, you use this first.
Right. Yeah, that's another little extra piece. So, and also think about it. They're the reverse of sine and cosine, so reverse the inside. But it has that extra piece too of absolute value of u. That helps as well. So if u is equal to the square root of x, then du is equal to 1/2 square root of x on the bottom, dx. We know the derivative of that. We've done it 100 times. Everybody agree? Okay. There's nothing in front, so I'm going to go straight to setting up this fraction. That derivative actually would all be on the top, technically. But I could put the 2 square root of u on x on the bottom, but for right now, I think it might be a little better to keep it away from the bottom until I get the bottom done. And then I can bring that down. Inside my absolute value bars, I'm going to put the square root of x. Inside of my square root, I'm going to put the square root of x squared minus 1. And then we're going to talk about all the different things that we need to do. First, we need to fix the inside. So when I square a square root, doesn't that drop? So is that just going to be x minus 1? All right, that's good. This absolute value bar sometimes doesn't need to stay. You need to think about the fact that when you take the square root of a number, is it always going to be positive or negative? It's always going to be positive because that's what the calculator gives when you hit the square root button. So I don't really need those. And I'm going to bring that 2 square root of x down to go with it. What do these two make? X. Whoop. So the key here is this can kind of be shifted down because it's a denominator, and denominators go with denominators. And the absolute value bars can drop off because the square root of x is not going to be negative because we're not solving. We're not putting plus or minus on it, are we? And that's all you had to do, that one. Now, if I put cosecant in it, it'd be the same exact thing with a negative on top. Do I have to do one? Does anybody need one for cosecant? Do you understand what cosecant does? It's only the same thing as this, just with a negative. Now here's the trick. Look down at the bottom at your integration formulas. What do you notice? Don't tell them. Everybody else already seen this. I want the two of you to tell me what's different about those integration formulas. Well,
I mean, this is like the...
But what I'm asking is, I have 6 formulas up here with derivatives. What do you notice about the integration formulas? There's only 3. Because you do the other 3. If there's a negative in the problem, you're going to bring it out front and not even worry about it and just do the 3 that don't start with a C. Does that make sense? It's not wrong that I could do the other 3. It's just they don't.
So we'll never have a problem with it?
I don't think so.
If you can memorize, just like, if you can memorize the first 3, 17, 19, 21, you should be able to memorize the other 6.
Right. Because they're very similar. The big difference is there isn't 1s down there. There's A's there. Everybody agree? That A number, we can work with it and we can make it work. But once in a while, they start off with putting some 1s in there, and all of a sudden they go into not putting 1s. So it's a little bit different because, unfortunately, not every question has a 1 added to it or 1 subtracted or 1 minus it. So because of that, you got to know where that number ends up in the answer. And once you learn that, it's a piece of cake. All right. So these are the notes for 5-9, integration of inverses. All right. So we talked about a couple of things before y'all came in, so I'm going to reiterate that for you since you didn't get to hear it. When you look at the derivative formulas, there's some hints there that can help you with the integration if you don't have the formulas in front of you. If you have a square root on the bottom and the x's are after the subtraction sign, then it's going to be arc sine or arc cosine, right? Because secant and cosecant put the x's first. Secant and cosecant also have the absolute value of something in front. And then tangent and cotangent don't have square roots in it at all. So that's a pretty good clue that it's going to be that if you see a plus sign with 2 things on the bottom and no square root symbols at all. So this doesn't have absolute value bars in it, so that tells me it's arc sine. Does everybody see where I'm going with that? Okay. Because there are no absolute values here, and this has got a square root, can't be tangent. The formula on your formula sheet has an extra piece. They square this A. So like if this was 1, 1 squared is 1, and it looked like the other formulas, right? But what if it was 2 squared? Okay, well that 2 squared ends up always over here on the bottom, because think about it, that's a number.
So we actually use the number squared? Or
No, you put the number over there that's not squared. Okay? But the key here is this number that's here will already be squared, and you have to unsquare it. Okay?
But that's not going to get that number that's in the original form. You have to square it.
Right. Now, the problem is the first couple examples I have a 1 there, and so it's not real obvious what I'm doing. Okay? And this one also has numbers to evaluate it with, but anyway. All right, so the first thing you have to think about is 1 squared makes 1. What squared makes 9x squared? Okay? Everybody with me so far? Have I lost anybody? Okay. Then a is equal to 1, and u is equal to 3x. The derivative of 1 is not going to affect your problem, right? But the derivative of 3x is going to affect your problem. Because the derivative of 3x is 3 dx. And I don't have a 3 up here. Because up here is supposed to be du. Does everybody see what my problem is? So I got to put a 3 and put the 1/3 in. Once I do that, I can go straight to filling this formula in. 1/3 arc sine, put the u stuff on top, put the number on bottom that was a, plus the c if it don't have numbers on it, but this one does. So I'm going to evaluate the first fundamental theorem of calculus. So this one doesn't have a plus c because I got numbers on the outside, but normally you would put plus c there like the formula shows, but I don't do that when I've got numbers on the outside. So I do 1/3 arc sine of 3 times 1/6. I'm going to just throw that 1 away. Minus 1/3 arc sine of 3 times 0. So 3 times 1/6 is how much? 1/2, okay? So we got to again look up where is it 1/2, and we'll come back and do that in a minute. And then 3 times 0 is 0, so we got to look up where it's 0. Everybody with me so far? And I just threw that 1 underneath the 3x away because I didn't need it. I'll have to see out. Sine is a half at pi over 6. Isn't that what we said yesterday? It's the first line up from 0. So 1/3 times pi over 6 minus 1/3. Sine is 0 at 0. Whereas I can only use quadrant 1 and 4, and it's 0. So that means it's pi over 18 is the answer to the question. Now, not all of them will have an answer, because if they don't put numbers on the integration, then I don't do anything, and I just put plus c on the end, and it's a lot shorter question when you do indefinite differentiation. But when you do definite integration, you get a number. All right, we're going to look at another one. And unfortunately, this one again has a 1 in it, so it's not focusing in enough on that formula. But the third one I have doesn't, so that'll help us out a little bit. Okay, we looked at the formula that tangent has addition. So in the integration formula, it has an a squared instead of 1 there. And that comes out to be, and hold on just one moment and let me look up one thing here that I've written on my paper. Okay, don't y'all find it odd that number 18 on, not 18, but whatever sign, arc sign on your formula sheet doesn't have a 1 over a in front, but the other two do?
Yeah.
I wonder if that's a typo.
You want me to look up on Google?
Yeah, that wouldn't be a bad thought. Because if that was the case, I'd need one more thing in that. Well, I put it in.
Oh, you're talking about the last one.
Well, I mean, I put 1/3 in front of it.
Yeah, but 1/3 ain't 1 over a, is it?
Yeah, that's what I'm saying. I'm wondering if, I mean, the 1 over this would be 1. And so I'm just wondering if there's a piece of that formula missing, and that when I put a number in there later that's not a 1, because all the other twos have 1 over a in front. So
Even if you have one part of 1 over a, I mean, a is, like you said, it's still just going to be 1.
for this one, it wouldn't mess up my answer, but if for one later on, it might. So it'd be good to look that up and just make sure that's not a typo in this textbook, because these formulas, you know, it's easy to mistype in something. But it might be because of which trig function it is, and not something else. Have you been,
I'm trying, they, like, it doesn't come out specifically, but
did you put integration of arc sine in the Google?
formula for integration of arcsine. You can actually just do integration of arcsine.
Yeah, and see what comes up. It might come up a little different. Because what I'm thinking is, y'all, that when you look at this question, and this is 1 squared is 1, and this is 2x squared is 2, see, a over 1 over a is going to be 1. But I'm wondering if I put a 25 there, it'd be 1 over 5. And I'm wondering why sine doesn't have that in front of it.
I checked it, it said arcsine of x dx equals x arcsine of x minus, in parentheses, negative square root of 1 minus x squared, parentheses, plus c.
Okay, let me come look at that. Okay, so now you can look at how you set it up. You've got your 1 over a out in front, that's 1 over 1 that dropped off. But we had to put some du work in here with the 2 on the top and the 1/2 in front because that's the derivative of 2x. And that's what's really important, is to remember this 2x right here has to have its derivative in front. And then we put the u over a, which 1 didn't affect. So I think in our next question, we'll see a better, really true sense of how that a gets used because I didn't put a 1 in for it. I don't know, I dropped it somewhere. Oh, it's laying right there.
I just found 3 pictures online that don't have it in it.
Okay, all right, then we're good. Then there's no 1 over a in front of the sign, and that means that you really have to pay attention. Okay? All right, so in number 3, no. The integration of 1 over x, square root of 4x squared minus 9 dx. Now, I see a square root. I see that the x's are first inside that square root. I see something on the outside. Granted, it doesn't have absolute value bars on it, but that's okay.
It's going to be positive anyways.
Exactly.
It's not like it really even needs
And there's not absolute value bars in the integration formulas either, is there? That's because that's part of the derivative work, not the integration work. So when you look at the formula for the integration, du, u squared minus a squared, it's almost identical to what we saw in the derivative work, except for the absolute value bars. Everybody agree? And the a. Because in derivatives, there's always a 1 there. So, the first thing we need to do is we need to break that down into 2 squared, 2x squared, and 3 squared. So, a is 3, and u is 2x. Is everybody with me so far? Do I have du? What do I need to put up here for du? A 2. Now, let's talk about the rest of the formula now. This is supposed to be equal to 1 over a arc secant of the absolute value of u over a plus c. Did I have absolute value bars on that other one? I probably should have.
Are we just solving this one or doing this one between?
We're just going to put a plus c on the end of it. So first of all, we have a 1/2 that's in our problem. But then we've got to multiply by 1 over a. So what's 1 over a? 1/3, right? Because a is 3. It's not 1 anymore. Does everybody see that? This half is the part of the du work. This 1/3 comes from the fact that the formula has a 1 over a in front of it. No, there's no squares over here on this side of my formula.
Yeah, but
We're unsquaring it to see what it was. No, it's part of the formula, the negative is. Because if I put that negative in there, it'll square out and be plus. No, that's not what you want. But that was a good question. All right, I got to do the absolute value around my u. So that's 2x. I got to put it over a, which is 3, and plus c because I'm not working it any further because I don't have anything to plug in, right? But I do need to multiply these two together and say what? 1/6. So you just got to clean up a little bit if it's indefinite. Now, yeah, it is. It's
you don't have to do any of the.
other math. So this one has absolute value bars in it. Makes me wonder, why do the others not have absolute value bars in them? Well, here's why. I had to think a minute so I could explain this to you. So I'm going to go back and we're going to look at the first one we did. In this problem, these were already squared, so when I square root them, I automatically made them positive, right? Okay. In this one, I took each one of these and square rooted and automatically made them positive. But in this one, there's an x outside, and he could be negative because I didn't square root to get him, and that's why there's absolute value bars on it. Because there's a random x out here that's not in your radical. So that's why you have to put absolute value bars.
So, we don't really mess with that x, though, right?
It kind of does, and I want to go back and explain one last thing in this one because this is where I wanted to focus on the x at the end. Okay, in the original problem, what do you notice right here? du. So I might have one thing wrong in this problem. I didn't even notice that. All right, we'll go back and focus on that because I want to focus on this extra u. So if that extra u not only causes you to have to put absolute value bars, but we need to talk about that because that might affect our du work. I don't know if it will or not. We'll see. If this is u, this is also u. What's missing? That half should have been in here. Now, let's focus on that a minute. If that's the case, if I put this 2 up here because it's part of the du, and this one was missing a 2, and I put it here too, what do these two 2's do? I don't need that half out there, so let's take this half off and make that back to a 1/3. So that's something you're going to have to be real careful about. If they're missing something, sometimes they're not missing anything. But that's something you want to go back and look at after you finish the question. Double check everything. This is u, the inside is u, they have to match. Whatever you have to put on this, you have to put it on the top as well because it's also part of the du here, right? Now if I already had that 2 up top, then I would have been putting a 1/2 in the problem and I'd had to put a 2 outside. But because there wasn't either one of these, this had to come because it's part of the du. This had to come because it's part of the u. They canceled each other out. It's why we don't see them, but we have to put them back. And they would cancel each other out outside. Exactly.
What if that x on the outside already had a 2 on it?
Then you would have had to have the half out here. Yes. If this had a 2x already here out on the outside and I didn't need to put a 2 here, then putting a 2 on the top puts a half. So technically, let's talk about that one last time. So if I take this 2 and say I put a half out here, for example, and then I put this 2 down here, that means I just put a half in that problem and I just put a 2 out here. What happened? So that's why if you put 1 on top and bottom, you don't need anything out front because it cancels.
I was going to say, why do you have 2? If you put the 2 on the bottom,
if you put a 2 on the bottom, it puts a regular 2 out here. If you put a 2 on top, it puts a half out here. They cancel out, so that's why it doesn't look like I did anything. Okay? Because I put 2 2's in the problem. All right. So that's why you got to be careful.
Yeah, like the formula in the battery.
Right. You got to put it in the formula. All right. Let's look at another one. Okay, suppose I have no, and they're going to throw a few questions, by the way, in here that don't fit this to see if you can pay attention and catch on to what fits it, what don't fit it. And there'll still be a few more, I think, that do some evaluating. And I don't know that I need to do every one of these examples I have, but I'm going to try to choose some of these examples that I have that really fit things we've looked at as well as things that we're doing now. So that obviously looks like they squared x and squared 1. Is the derivative on top? Then that must not be arc sine. Would you agree with that? Okay. And the power's higher on the top. What does that tell me when I do integration work and the power's higher on top?
Yeah, I'm
I need the long divide.
Oh, yeah.
So x squared plus 0 x's plus 1 divide, yeah, equals, that's right, divides into x cubed plus 0x squared plus 0x's plus 0. I know that seems a little silly, but it helps line things up for you. All right. So how many more x's will it take to make it cubed? 1. X times x squared is x cubed. X times 0x is 0x squares. X times 1 is 1x. Change the signs and add. These drop out. These drop out. Negative 1x plus 0 is not enough terms to divide into. Would everybody agree with that?
So what did you just do?
I multiplied x on the top times all of those and changed the signs and add because you're supposed to subtract and division.
Oh, okay.
And I don't have enough terms left to divide into. So my integration problem now is x minus 1x over x squared plus 1 because I had 1x left. And I put it back over what I was dividing by. So this is how many times it went minus my remainder over my divisor. Now I'm going to put an integration symbol right in front of that fraction because we're going to integrate each of these individually because that's what we did before. If you integrate x, what do you get? Okay. Now, do I have the derivative on top? Almost. I can at least take the derivative of the bottom and it looks like the top except it needs a 2. So I can put a 1/2 in front and go minus 1/2 ln of x squared plus 1. Will x squared plus 1 ever be negative? Then I don't need parentheses. Absolute value bars, I can just put parentheses. And because there's no numbers on it, I can just put plus c and I'm done. So they're going to throw something in once in a while that looks like the bottom looks right for arc, sine, or cosine, or tangent, but it's not because the top's got too much stuff up there. All right, in our next example, we have a square root in there. Let's see if we need to do arcs or if we need to do some kind of square root power thing. Okay, in number 5, we have 1 over the square root of 25 minus x plus 1 quantity squared dx. Now, in this question, hey, it's got a square root, it's got minus, it's got the x stuff second. Has it got a chance of being an arc thing? Okay. What's the derivative of the inside here? 1. That's up there. So it must be. But this right here needs changing to 5 squared because a is 5. And this is u. And which trig arc is this? Sine. So arc sine doesn't put the 1 over a in front, does it? All right. But it does put the a underneath the u. Plus c. Man, that was easy.
I got like 5 times or arc in general.
Mm-hmm. All right. Our next one is another problem with a square root in it that we've got to see. Does it fit anything, or do I need to do like to the 1/2 power type stuff? You know what I'm talking about? Power rules with fractional radicals. So let's see. Gosh, I wish I could remember what the original problem on this one was. I think this is the original problem, to be honest. It's just hard to tell because I wrote on it. All right, I believe that's the original problem. So we'll see if this works out. First of all, it's a square root with the variables at the front and extra variables on the bottom. What does that tell me? Arc secant or arc cosecant is our possibilities. And since we're not doing the ones that start with C, it's got to be arc secant, right? I know it doesn't, so we're going to take it out. All right, we got t squared on the outside, so this must be t squared squared. 1 squared. Would everybody agree with that? This is u, this is a. Isn't u supposed to be out here? Everybody agree? Because this is arc secant. What's the derivative of the inside? 2t. Do I have a 2 on the top? Well, then I'm going to put a 1/2 out here. So I took the negative out because that fixed the negative so that I don't have to go with the words that start with C. Technically, this problem is arc cosecant, but they don't integrate to arc cosecant. So because of that, if we bring the negative out, we don't have to worry about that, and we can just do 3 words. So negative 1/2 arc secant it's U over A, right? Absolute values. Do I need absolute value bars over t squared?
No.
Do I need this 1 down here? Now, one other thing. Is there a 1 over A out in front in the formula?
Yes, but we don't.
Right. If 1 over A is 1 over 1, then I don't need it. So my final answer to this problem doesn't need that 1 down there either.
If I could ever remember all these formulas, this would be.
All right. The next one we're going to evaluate, and I'm going to probably, I think this will pretty much, give you an opportunity to see what you need to see with all this math and be able to do some for the homework, I hope. Okay, number 7. Integrate 0 to 1 over the square root of 2, arc sine of x over 5 over the square root of 25 minus x squared dx. So our focus is going to switch a little bit because the word arc sine's in there. Is the derivative of arc sine in there? Well, let's separate it out and see. So let's take the arc sine over here, and let's move this radical over here closer to the du work and see if that really is the du. So first of all, x, we squared it and we put it in here, right? 5, we squared it and we put it in there. What's the square root of x? I'm sorry, I didn't ask the right question. What is derivative of x is what I meant to say. 1. Well, that's there. That's all du. So if that's all du, then when you integrate this, this means I'm integrating u du, because this is u.
That means the bottom right there is
No, it just means that that's gone. Integrate this. So that all is u. How do you integrate a letter?
You just do
put a square on.
1
Put a square. Exactly. Not plus c. Gave us numbers to evaluate. 0 to 1 over the square root of 2, which I really don't like that, but anyway. That's what they gave us. What is 1 over the square root of 2, mate?
square root of 2 over 2.
Well, I got to multiply that times a 5. I mean, divide that by a 5. So that's going to be the square root of 2 over 10. Square root of 2 over 10 minus, and all that's going to get squared, by the way, minus, can we put the half on the outside so we don't have to write it twice? Okay. Arc sine of 0 in that would be 0. Everybody agree with that?
Sure.
Yeah, arc sine of, and it's got to be squared. But that's going to be 0, right? Because that 0 is on the blue. You know,
There is on her integration.
yeah, it's running together. So, in this problem, y'all, the rest of this would have to be typed in the calculator because I don't know anything that's the square root of 2 over 10. But we know arc sine of 0 is 0, so this whole part of the problem dropped off. We just got to figure out what 1/2 with the parentheses around the whole arc sine of the square root of 2 over 10 quantity squared, round it off, would be. I don't know why I have 16 examples of notes for this, but I guess I was just trying to give you all a lot of variety. but I think I've got to do one more after you get this one done. I might have to finish this tomorrow. I hate that. I'm going to do one more. I don't have the answer, y'all, to tell you what the answer is. So y'all need to agree on the answer. All right, everybody agrees? Your square has to be on the outside of the whole thing. Oh, okay, that's probably what it is. All right, I'm going to do one more, and the only reason I got to do this one is because this one, you have to know a little bit more algebra to get started, and then it works the same. And I chose this one because I think it'll be quick.
What was the answer?
I don't know.
0, 1, 0, 0, 6, 7.
All right, we'll look at your parentheses in a minute and see if that's what it is.
Yeah, our parentheses are wrong.
All right. Somebody multiplied out the bottom of the question, and unless I can see the parentheses squared and the parentheses squared, it's not much good to me. But would everybody agree that if I can make these two into parentheses squared, then I don't know if it's which one it is? Well, the problem here is this. X squared minus 2x plus something, not 1, plus something is the first one. And then there's something else over here that's squared that I got to figure out. So I got to do the complete and the square process to figure out what this number is so I can figure out what plus what makes 2. So negative 2 divided by 2 quantity squared, you know that fill in the blank stuff we did with conics? Tells me that's a 1. And 1 and 1 make 2. So 1 squared makes 1, and plus this 1 made that 2. Because somebody added the like terms together instead of leaving it in a format in which we can make this back into parentheses squared. X minus 1 squared. So you have to break it off. In fact, don't even write the number in the problem down. That's the constant. Take your middle term and divide it by 2 and fill that in, and then figure out what plus that made 2. Well, 1 plus 1 made 2. And the only one thing that squares to make a 1 is a 1. Now pretend for a minute that was a 9 up there. No, that's not a good choice. Pretend that number up there is a 5. 1 plus what makes 5?
4.
Oh, what did I square to get the 4 over here then? Does everybody see where I'm going with that? These two numbers have to add up to this, and then you have to unsquare that second one to figure out what it was. It just happens in my problem to be a 1, and then squares to be a 1, so that's a little deceiving. Now, this is plus no radicals, so that must be some arc stuff. Yep, it's arc tangent of U over A. A's 1. Do I need to put it in? Do I need to put a 1 over A out front? Do I need any absolute value bars? Did they have them in the formula set? No, because the only reason they ever have extra absolute value bars in a problem is the ones that have that extra piece on the outside of the radical, and this is not a radical problem. And then we're going to do it from 0 to 2. So arc tangent of 2 minus 1 is 1. Arc tangent 0 minus 1 is negative 1. So we got to figure out where tangent's 1 and where tangent's negative 1. Isn't tangent 1 where they're alike, or y over x cancel out? Well, that's pi over 4. And it's negative 1 at negative pi over 4 because it has to be in quadrant 4 to be negative.
Yeah, but then it comes out to 0.
2 pi over 4.
No, because it's subtracting a negative. So it's 2 pi over 4 or pi over 2. Now, that's half of the examples that I actually have in my notes, but I'm out of time. But that should be enough for y'all to be able to do some of this work. So we're going to try and get as far as we can in it. And I think I've given you enough input into this to probably get you, I think, to 24 in this assignment. So I'm going to say 2 through 24 on page 390. 2 through 24 on page 390. And we'll see If the last few questions, you have to complete the square and the radical. And that's just a little bit more than this, but basically the same concept. So I'm going to try to see if you can do it without the radicals first, and then we might hit a few more tomorrow. All right, now, just briefly, let me tell you a couple of more things. One, I skipped section 7, but I'm not coming back to it till we get some section 6 done. Tomorrow, we are going to work on a word problems. We're going to do word problems. I will have to put it in Canvas for those who aren't going to be here, so I think I'll just put it in Canvas for everybody because I didn't leave enough space on the worksheet to write anyway, so I might as well. And you can just do it on notebook paper. It relates to what we studied in section 6 on all those different formulas. Okay? I was going to wait and do this one later, but based on where we're at, I think that would be good that we can check this homework on Monday. We can turn a worksheet in on Monday, and Monday we start chapter 6. Because section 10 is not part of our curriculum. That's BC calculus. And section 7 is, but I'm not as concerned that you know section 7 as I am chapter 6. That's a whole chapter. So you have 2 assignments, one tonight and one tomorrow that we're doing in class, and both will be due on Monday. Is that understandable? And if we have trouble with something, then we can try to finish any little things you have on Monday. Yeah, you can work on the homework tonight. Now, also remember that I asked you to take a college placement test, and that I put that out there in Canvas. It has the answers in one document and the test in the other one. Sit down and take it, and then come in on Monday and tell me what you don't understand. And each day next week, we'll practice those questions you don't understand and go over them to be ready for a Friday when you take the college placement test for me one more time.
How much time should we give ourselves?
You can only have 55 minutes. So if you want to sit down and take it like the real test, 55 minutes is the max. And without a calculator. Okay? Any questions? Everybody okay with that? All right, let me see if I even have this document so I can at least show y'all what the word problem thing looks like. Yeah, I'm recording for Chris so he can hear anything I might say about this worksheet. Oh, that's pretty cool. Do I have the word problems? No, I don't. All right, I'll have to scan those because I don't see the word problems worksheet in here. But wait a minute, so it might be on my flash drive. Let me see. But it's not that bad a worksheet, but it is very similar to what was in the textbook. And no, I do not have a copy of it, so I have to go scan it. But I'll put it in there, and I'll put it today before I leave. That way, if somebody wants to go ahead and start it whenever they have the time, they can start it whenever. So you got a book assignment, you got your college placement test to practice. If you want more practice, it is not required that you do it. It is your option. But there probably are some different questions on there from the first one. There always are. Does same kind of skills, but always different questions. And then you've got your word problem packet that I'm going to put out on Canvas. We good? Okay. I'll stop the video then and